third part for that chapter 18, amino acid and protein. We're going to look at the quaternary protein structure. Well, this is the way in which two or more protein chains aggregate to make a larger protein, and those are order structures. So learning objective, being able to define what is a quaternary structure and give also a few examples. When I look at this, I'm going to look at here how two or more protein chains can aggregate. Examples here are hemoglobin. This is a conjugated quaternary protein that has 4 polypeptide chains. Well, 2 of them are alpha, 2 of them are beta. I'm not going to go into the details, but they're held together by hydrophobic interaction. Hydro, water, phobic, hate the water. Now, hemoglobin is very important because they contain an iron atom. The iron is going to be the one that helps to combine with oxygen. So hemoglobin is the way we carry the oxygen in red blood cells, erythrocytes. In the lungs, oxygen binds to the iron, so each hemoglobin can actually have a maximum of 4 oxygen molecules. When the tissue needs oxygen, oxygen is released and the carbon dioxide is picked up and goes back into the lungs. Hemoglobin is a cellular protein, normally found only inside erythrocyte and carried through the body inside the red blood cells. Another important example of a quaternary protein structure is the collagen, major constituent of connective tissue. Basic structural unit of collagen, called tropocollagen, is 3 intertwined chains of about 1,000 amino acids, each of them. They are loosely coiled in a left-handed, meaning it's counterclockwise direction, and those 3 of those coiled chains are going to wrap around one another, that time in a clockwise direction, to make a stiff triple helix in which the chains are held together by hydrogen bonds. So remember, hydrogen is interaction between a negative and a positive charge. I'll let you read the protein structure summary. It's a very good summary, and then just a worked example right here. Identify the following statement as descriptive of a secondary, tertiary, or quaternary molecule of a protein, and also be able to identify what type of interaction stabilize each of those structures. First one, polypeptide chain has a number of bends and twists, making a compact structure. B, polypeptide backbone forms a right-handed coil. And C, 4 polypeptide chains are rearranged in a spherical shape. So when you look at those, you need to first consider what you know about secondary, tertiary, and quaternary structure. Quaternary structure is when you have more than 1 polypeptide chain present. Right-hand coil is characteristic of one type of secondary structure. Many bends and twists, compact structure, are characteristic of some kind of tertiary structure. So when you look at this, A will be a tertiary structure stabilized by hydrophilic and hydrophobic interaction, such as salt bridges, hydrogen bonds, and disulfide 2-sulfur atom bonds. Secondary structure, you have hydrogen bonds between backbones, and you're going to have here the pletochete, beta pletochete, or alpha helix. And quaternary structure, same interaction that stabilizes tertiary structure, and this is when you have 2 subunits that combine together.